Here's the game. There we go, that's that. Let's get into the make code editor and get on. We're going to call this pixel drop, that we're going to have a game state variable, and then we're going to control the game through the forever loop. Well, the first thing we need to do is we want to make it so that we have a pixel which goes across the top and then just cycles over and over again. I'm going to call the two pixels, really, the two main pixels, the top pixel and the drop pixel. The X position is the horizontal one. So the X position here is 0, and then the next one is 1, and the next one is 2, and next one is 3, and next one is 4. When it comes to the vertical position, it starts with the top row being 0, and this is the Y position, we could say, and then as you go down, the number increases. So this row will be Y equals 0, the second row will be Y equals 1, the third row will be Y equals 2, and so on. Well, the pixel that's circling at the top, it's not going to change its Y position. It's always going to stay at Y equals 0, and it's just going to go across in a horizontal way. So we need to remember which position it's in. At the beginning, we'll set top pixel to 0, so it can start right on the side. When we start the game, we'll do the typical thing of indicating how the user should start. Then if we get out the A button, we also need another logic loop. First, we need to make sure that the game hasn't started. So we need the comparison. If the game state is equal to 0, well, then we want to start the game. To start the game, we just change the game state to 1. Firstly, this starting position is only going to happen if the game hasn't started. But if the game has started, we want to start showing the top pixel cycling. And to do this, we're going to use a function. We'll go into advanced and create a function. And I'm going to call this handle top pixel. When the forever loop recognizes that the game is being played, we will call this function. And it will handle the top pixel. Now, what do I mean by handle the top pixel? We can go into this LED. We want to plot the top pixel. But where is the top pixel? Aha, it is at top pixel X position. And then we want to increment that. Set top pixel to top pixel plus 1. Let's just put a pause in the system so we can see things happening a bit more slowly. Let's just say half a second. And then I'm going to unplot the previous one. So we need the maths because it's the position minus 1. Right, let's do the simulator. Right, so we can see the top pixel is moving across. In fact, it's still doing it now, but we can't see it in the LEDs. Because the X position is now like 25, 26, 27. It's just continuing to grow. So we need another if statement here. If you got to 5, then, well, actually, you just want to change that back to 0. And then also we have another situation, because if the X position is 0, then that means the pixel had just finished in index 4. So we need to put another if statement here before we increase its value to say if the X position was actually equal to 0, you need to unplot X equals 4, Y equals 0. Let's see how it works. Great, it works perfectly, but you can see we have a small problem, which is LEDs are lit up from the arrow. And to handle this, I'm going to make another function. I'm going to call this function clear screen. I could just put in show LEDs here, like this. Well, the problem is we keep on seeing the arrow, so it makes sense really to put this function after the arrow. Now we want to continue using the A button, and in this case we want the A button to start a drop pixel from falling. Let's make a variable which is drop pixel x pos. The microbit will set the x position of the drop pixel to what? Well, we want it to look like it dropped from the position of the top pixel. So we're going to set the drop pixel's x position to the top pixel's x position. We want to make another variable which is the drop pixel y position. I'm going to set the drop pixel y position to 0 at the top so it's ready to fall. I'm going to make another variable which is if you just mash button A, it's going to go crazy on this game and everything will be falling down. So I'm going to say lock drop pixel. At the start of the game, I'll just set lock drop pixel to 0. And when the player presses a button and activates the drop pixel, we want to set the lock drop pixel to 1 so that it is locked. It won't continue to make pixels fall everywhere. Inside the game, the main game loop in our forever loop, I want to have something that says if the drop pixel y position is equal to 0, then handle drop pixel. Call handle drop pixel. Oh, if it's bigger than or equal to 0. I'll put the drop pixel y position to -1. When the game starts, the top pixel will start cycling, but nothing will start falling because the drop pixel y position is not equal to 0. So what's in the function handle drop pixel? Just like with the top pixel, we want to plot the position. In this case, the x position of the drop pixel is not going to change. It's not going to move left or right. It's always just going to be equal to its whatever x position we set when we press the A button. But the y position is going to change. However, we've still got a variable for that y position, and so at this point we're just going to use that. Okay, so we plot the x position and the y position, and then we unplot something which is in the same column, but one above, the y position -1. We want to have this check that if y position is equal to 5, then we're going to set the drop pixel y position to -1. Because this isn't cycling, this is just resetting. Also at this point, we can unlock the A button so that the next time the player wants to make a pixel drop, they can. We still need to increment the drop pixel's y position now. But it's the drop pixel's y position to drop pixel y position +1. Okay, and let's see how this goes in the simulator. Game starts, press A. And there we go. And you can see when it's reached the bottom, it no longer unlights that last LED because it didn't reach the next LED. And that's what we want to do, because we want the player to fill up all that bottom row. So this is where we're going to integrate the use of an array, because we need to remember which drop pixels have got to the bottom. We can see it visually, but the microbit at the moment has no way of remembering that. And so we're going to set up an array. I'm going to call it LEDs lit at bottom. And it's just 5 zeros. Each zero from index of 0, 1, 2, 3, 4 is going to represent the pixels at the bottom. So when a drop pixel reaches that bottom position, we want to change one of the values in this array to a 1 so that the microbit remembers that a drop pixel did reach that position. We need to go back into our handle drop pixel function. When the drop pixel reaches this position 5, we can also tell the microbit, hey, you've achieved what you wanted to do. So we need to go into the arrays and we need to modify a list LEDs at bottom, and we need to set the value at drop pixel's X position. It's at that place in the array. The drop pixel's X position corresponds to which one of the columns it reached the bottom of, and we want to set that value to 1. In this case, to do this, we need to go back to start and we need to create another variable, which I'm going to call filled. And I'm going to set filled to 1. I want to put in really just the value 1, but I have to do it as a variable. The next thing we need to do is we need to get the microbit to think about, has the player filled up all these values yet? And so to do that, we're going to create a function which is called GameWinCheck. We will call the function GameWinCheck when all the other things have happened, all the pixels have dropped. We need another variable, lit LED count. So we're going to, every time the microbit checks, we are going to set lit LED count to 0. So we pull in this for loop. How many times are we going to cycle through this loop? Well, we want to do it once for every value which is in the array. How many values are in the array? Well, we just use this function here, length of array, and change that to LEDs lit at the bottom. Now, we do the logic check. If the value in that array is equal to, get value at, is equal to 1, then set lit LED count to lit LED count plus 1. And get value at what? You can see at the moment I've left this as 0. Drag over this index here and put it there. If the LED count is equal to 5, in other words, all the LEDs are on at the bottom, then we want to change the game state to, let's say, 2. We can also just give some basic winning thing. There you go. And then, because the player might want to play the game again, we need to reset the array and make all the values 0 again. So we will use another loop in exactly the same way. In the LEDs at the bottom, we will set value at index to, we need another variable. We're going to call this one empty. And empty is essentially going to be the value 0, so that we can put it into here. Okay. We can reset the game state to 0, which will start the game all over again. Whew, okay, so that's most of it. We're almost there. We're going to put a secret in as well. Let's try it on the simulator. Press A, game starts. Press A again, pixel drops. Press A, press A. Nothing happens because it's locked. Oh dear. Okay, there we go. We won. The game works. Everything works. Right. For fun, we can add in a little secret that you only know if you've seen the code. So I'm going to create a function called secret. When the B button is pressed, if it's the end of the game, if the game state is equal to 2, then we can run this function secret. And in fact, all this function is going to do is we're just going to have some funny animation. Also, the clear screen, we can actually make this happen faster, because when the microbit does the LEDs, it actually pauses for a short time For index from 0 to 4, unplot x comma y. Y. And then I can simply unplot all the x's and all the y's, and it will work through and clear the screen. Beautiful little way of clearing the screen. The microbit will do that as fast as it can with no delays. Game works. Let's download it and check it out. There's a bug with the code. Anyway, that should work. Right, I'll press B. And then we get the secret, which is the dancing microbit guy. So you can see there's a little bug where the drop pixel freezes sometimes. We'll come back and we'll fix that. But the rest of the program works fine, and we even have a little secret in there for those in the know. So what was going on with that bug? Well, when you press the A button, the computer did check if the game state was 1 and therefore the player was playing the game. But I forgot that at exactly the same time, we also needed to check whether the lock button was 0 or 1. And so because there was no check, every time the player pressed the button, that meant that a drop pixel was dropping. In our next project, we'll be making an even bigger game, which is where you will use buttons A and B to dodge pixels that are falling down. Each pixel that you dodge, you'll get 1.4. So this is more involved, but it's essentially all of the same ideas that we've been using in this game.